In this video, we will discuss the domain and range of a multivariable function, and also describe its level curves. So here we're given a function of two variables. F of xy is the logarithm of 9 minus x squared minus 9y squared. And we're asked to sketch the domain, say what the range is, and describe the level curves. Now let's do part C first, since it's maybe the simplest. So part C, describe the level curves. So remember, a level curve is just the solution set to an equation like this, where you set the function equal to some constant. So C here is just some real number constant. So let's write what our function is. And the idea here, when you want to see what the level curves of a function are, is to start by doing this. Set the function equal to a constant, and then just algebraically manipulate it until it looks like something familiar, if possible. So in this case, let's try to get rid of the logarithm. So let's exponentiate both sides. So the logarithm will go away on the left, and on the right we'll get e to the power c. Now, let's just sort of swap things around. We'll move the x's and y's to one side of the equation, and move the constants to the other side. So we'll get something like this. 9 should be minus e to the c equals x squared plus 9y squared. And then you'll recognize this as the standard form of an equation for an ellipse. So level curves are ellipses. Right, because we have something times x squared plus something times y squared equals a constant. Okay, let's move on. Part A. What's the domain of the function? Well, if you look at how the function is written, there's one thing that we should look out for. We have a logarithm. So whenever you have a logarithm, we know that you are not allowed to put anything 0 or negative into the logarithm. So that means this quantity here in parentheses must be positive. So we have one restriction to look out for. We need this quantity in the parentheses to be strictly positive. It can't be 0, it can't be negative. So if we rearrange this, this is the same thing as saying x squared plus 9y squared is less than 9. Now if this less than symbol were an equal sign, this would be the equation for an ellipse, as we were just saying a minute ago. But it's less than. So let's think about that. First, let's divide everything by 9 to make it more like the standard form of an ellipse equation. So divide everything through by 9. So we get x squared over 9, which I'll write as x over 3 squared, plus y squared is less than 1. So, again, if this less than sign were an equal sign, this would be the equation for an ellipse. And since it's written like this, we know exactly what ellipse it would be. It would be an ellipse that is stretched by 3 in the x direction and by 1 in the y direction. So I'm going to draw this ellipse dotted right here. So the dotted line is the ellipse given by this equation, where it's an equal sign. Or another way to write it is that the original quantity that we were looking at is equal to 0. Okay, but it's not an equal sign, it's a less than sign. So that means we have the region inside. So this is the domain of our function. It's described by this inequality, and geometrically, it is the interior of this ellipse, not including the boundary. Okay. Lastly, discuss what the range of the function is. So, let's notice something right away. Again, let's look at the quantity that's in the parentheses inside the logarithm. This 9 minus x squared minus 9y squared. And let's notice right away that there's a maximum value that can take. It's always greater than or equal to 9. And that's just because x squared and y squared are always non-negative quantities, and they're being subtracted from 9. So this quantity is 9 minus something positive minus something positive. So it's, no, sorry, that should be less than or equal to. Right, 9 is the maximum value that this can take. We're starting with 9, and we're subtracting two things that are 0 or positive. So it can only get smaller. Okay, and if we remember what the graph of the logarithm function looks like, it looks like this, right? So that means we're not plugging in anything bigger than 9. And since the logarithm function is increasing, this is the maximum value. We're never going to get anything bigger than log 9. Now let's think if there's a minimum value. And you can quickly convince yourself that there's not. X and Y can get as large as you want, and you can get very, very small things. But we have to keep in mind that we're only considering things in this domain that we found in part A. So we're only allowing ourselves to plug in things in the interior of this ellipse. But if you recall what we said before, the dotted line on the boundary of this ellipse is exactly where the stuff in parentheses is equal to 0. So that means we can get as close as we want to making this quantity 0, because we're allowed to pick points inside the ellipse as close to the boundary as we want. We just can't hit the boundary itself. So that means that we're allowing ourselves to plug in things as close to 0 as we like, but not 0 itself. And the logarithm function has an asymptote here, and it dips down to negative infinity as you go to 0, so there's no lower bound as to what we can get out. Again, we can make this quantity in parentheses as close to 0 as we want, but it can't be any bigger than 9. So finally, our answer is that the range is negative infinity to log 9.